Hello guys, this is Sushant and welcome to your channel which is SciEngineers. We have been uploading videos for the mathematics section of the Mhtcet, and in the earlier video we had discussed on the topic of differential equation, and this is going to be the continuation part to it. Those who are new to the channel, I would like to tell them that we have over 50 plus videos for Mhtcet preparation for the mathematics part, and soon we will be starting with the physics section for the Mhtcet. For students who want more videos related to differential equation, there is a link which is given in the description below. So to get the regular updates, please hit the bell icon which is just beside the subscribe button, and also do subscribe to our channel. Do like our videos and do share our videos with your friends so that it helps them in the preparation also. In the current scenario, please do stay safe. So keep learning, keep watching, and happy learning, and let's get going. So in the earlier video we had asked this particular questions. The first one is the degree of the differential equation which will satisfy this equation. So as you can see this, they have given you the equation. It's not a differential equation because you can see there is no dy by dx term present in it. But I need to find what will be the degree of the differential equation which will satisfy this. Now in this you can see that there is a arbitrary constant lambda, and I know that whenever there is an arbitrary constant present, the number of arbitrary constants define the degree of the differential equation, because that many times I have to take the derivative of the equation. So you have only one arbitrary constant, that means the derivative will be taken only once. So that is why your option is A. Moving to the next one, we have the differential equation of family of curves for which the length of the normal is equal to a constant. Now whenever there is the concept of length of normal is nothing but, let us see diagrammatically how it is. So if I have any function, let us say y is equal to f of x is any curve, and we have a normal which is drawn to it. So length of normal is nothing but the distance of these 2 points. That is, let us say this is my point P where the normal is drawn, and this is N where it is intersecting the x-axis. So the distance between P and N is nothing but the length of normal. Now the length of normal is given by the equation. So the Pn, the distance, is given by the equation y root of 1 plus dy by dx the whole square. Now this thing, since they have given it as constant, we'll take it as constant k because the constant is given as k. So this is the equation which I'm getting directly. Now squaring both sides, I'll be getting this as y square plus y square dy by dx the whole square is equal to k square. So y square goes that side. So you can see it's nothing but option A. Moving to the next one, the solution of xy dy by dx is equal to 1 plus y square upon 1 plus x square, 1 plus x square. So this is what the equation is given, differential equation which is given. And since it is not talking about particular solution, we need to solve this differential equation. So you can see that this particular differential equation comes under the form of variable separable method. So variable separable method is wherein we can separate the two variables, that is y and x. So on one side we have y and the other side we have x. So wherever dy is present, keep all the y terms on that side. So you can see dy is in the numerator. So we'll keep the dy terms, that is y terms, on this side, and dx, since it is in the denominator, I will take the dx on the other side. So all the x will go on the other side. So on this side we have all the y terms coming. So we have y from here, we have 1 plus y square from there. So all the y terms have gone to the LHS part. Now taking all the x terms on the RHS part. So I am having 1 plus x square upon the x goes that side and 1 plus x square stays where it is, and dx goes here. So we have the y term separated and the x term separated. So this is what is basically the variable separable form. Once you have the variable separable form, you need to just simply integrate both sides. So if I'm taking integration on both sides, I'll be having a plus constant c which is to be added. So what you can see is that the derivative of this, we can adjust a 2 and we can just write it as 1 by 2. So you can see the derivative of this is present in the numerator. So it's like 1 upon t form. So whenever derivative is present in the numerator, the denominator's derivative is present in the numerator. The answer for this is going to be log of the denominator. So this becomes half log denominator. Now this thing we need to simplify it. What we will be doing is we'll be taking 1 plus x square together and separate it. So 1 plus x together, x square together, and plus x the other part. So if I'm taking 1 plus x square together, this becomes 1 upon x, because 1 plus x square basically cancels with that term. So we have 1 upon x, and 1 upon x integration is log x. The other term is going to be nothing but x upon x into 1 plus x square. So x gets cancelled, and I'm going to have the integration of 1 upon 1 plus x square, which is nothing but going to be tan inverse x. Now since I'm having two terms as log and I don't have any log terms in the question given, what I will be doing is I'll be taking the c as log c. So I'll be taking all the log terms together. Since this is outside the log, we have a half. It's basically going to be root. So taking the log terms together, this is root 1 plus y square. Now since this log x was going that side, it becomes in the division. The log c goes that side. It also goes on the division, and this is equal to tan inverse x. So if I'm taking the log on the other side, that is anti-log, this becomes e raised to, so the log goes, and this becomes e raised to tan inverse. And the xc also goes that side. So what I will be getting is root of 1 plus y square is equal to x c e raised to tan inverse x, which is nothing but option. So in this particular video, we are going to be discussing on the various methods for differential equation, solving the differential equation. So let's see the first one. So the question is, we have to just find the integrating factor. So now, as you know that for integrating factor, whenever integrating factor is asked, so generally the given equation is going to be of the form of your linear differential equation. So linear differential equation, if you just recollect, it is of the form dy by dx plus py is equal to q. And the integrating factor is given by e raised to integration p dx. So in this, we need to find my dy by dx plus py is equal to q. So only thing which we need is your p. Now there is another form for the linear differential equation, which is nothing but dx by dy plus p dash x is equal to q dash. So here you have to understand, whenever it is dy by dx, this p is function of x. And if it is in the other way, that is dx by dy plus p dash x is equal to q dash, then my p dash and q dash are function of y only. And the integrating factor for this case will be nothing but e raised to integration p dash dy. So let us try to understand how to find, basically it is of this format or of this form. So now when we have dy by dx plus py is equal to q, you understand that p and q are functions of x only. So in this you can see that there are two y's, that is we have one y over here and y square. So bringing it down to this particular format is going to be quite difficult. Whereas in the other case, when we have dx by dy plus p dash, we can see that there is only one x which is required. As in this case also, we have only one x. So what we can do is we can take the y square on the other side and take the dy by dx on the other side. That becomes dx by dy. So I will be getting the equation directly. I'm writing it. It is y square dx by dy is equal to xy minus 1. Now with dx by dy, I don't need the y square term because the coefficient of dx by dy is always 1. So I'll be dividing by y square. So if I'm dividing by y square, this becomes x by y and this becomes minus 1 by y square. So because of that, what is going to happen is this becomes dx by dy, and this becomes, as I said, it is x by y. That goes on the other side, it becomes minus x by y is equal to minus 1 by y square. So you can see it is brought down in this format because we have only one x and we have the p dash. P dash is nothing but in this case minus 1 by y, and q dash is nothing but minus 1 by y square. Now since only integrating factor is asked, we need to only find what is p dash, which is minus 1 by y. So integrating factor is e raised to integration of minus 1 by y dy. So that integration, we know it is e raised to minus log y. This minus goes inside. This becomes y raised to minus y. So that becomes e raised to log, basically cancels out each other. The answer becomes y raised to minus 1. And y raised to minus 1 is nothing but 1 by y. Going to the next one, we need to find the solution of the differential equation. So this is the differential equation which is given to us. Now, first of all, we try to understand which type it is going to be in. So for that, what we need to do is first of all give the preference whether it can be separated or not, whether it can be of the form of variable separable or not. So in this case, if I take the e raised to minus y term outside, what you can see is we are getting two separate terms, which is only of x and only of y. You can just see dy by dx will become, I'm taking the e raised to minus y common, I'm getting e raised to x plus x square. So we have only one term of y, only term of y, and this is only term of x. So this becomes a variable separable form. So now taking the y terms together and the x terms together, y terms will be going by dy is a numerator. So dy, this becomes e raised to y dy is equal to, and the dx goes that side, and we get e raised to x square into dx. So now we need to just simply integrate and add a c. So e raised to y integration is e raised to y. This becomes e raised to x. This is x cubed by 3 and plus c. So you can see that the option is nothing but option C. So moving on to the next one, we have this particular differential equation which is given, and we need to find the solution for it. So now in this case, it is difficult to basically understand what type of the equation is going to be because it's not in the variable separable form. We cannot separate the variables, and also it's going to be difficult to bring it down to a linear differential equation. So let's see what can be done. So what we can do is we can take dy by dx together on one side and then analyze the particular problem. So let's say that x dy goes that side and dx goes on the other side, and x goes, so I'll be getting this as dy by dx with the x along with it is equal to x y raised to 5 plus 2y. Now I am going to be dividing by x, so I'll be getting dy by dx. So this x gets cancelled out and this becomes 2 by y. So after that, what we can do is this 2y, I am taking it on the other side. So this becomes minus 2y by x is equal to y raised to 5. Now I'm dividing by y raised to 5. So if I'm dividing by y raised to 5, this becomes y raised to 4 over here. This becomes 1, and over here I'll be getting y raised to 5, because you can see that this particular equation is of the Bernoulli type, that is Bernoulli differential equation. Because if I take minus 1 by y raised to 4 as t, I'll be getting the derivative over here. So I'm taking the substitution, that is t is equal to minus 1 by y raised to 4, because the derivative for that with respect to x is going to be the minus 4. So this becomes y raised to minus 4. So that becomes 4 by y raised to 5 dy by dx. So that 4 goes on the other side, it becomes 1 by 4. So in this place, I'm going to get 1 by 4 dt by dx, and I'll be getting minus 2 by x t, because I'll be getting the plus 2 by xt is equal to 1. So after this, I have to multiply by 4. So this becomes 8 and this becomes 4. So now I have this as my P and this is my Q. So the integrating factor, so let us just find the integrating factor. It is e raised to integration of P dx. So 8 I can take outside 1 by x dx. So that becomes e raised to 8 log x, and I can write that as x raised to 8. So now solution, the solution is going to be nothing but the variable that is t into the integrating factor, which is x raised to 8, is equal to integration of, that is q into integrating factor, that is 4 into x raised to 8 dx plus c. But I have to replace the t because that's not what I need. So I will be having minus 1 by y raised to 4 in that place. So this integration is nothing but 4 by 9 x raised to 9 plus c. So now we need to bring it and see whether I'm getting this particular thing or not. There is nothing in the denominator, so I have to just remove everything which is present in the denominator. So I'll be multiplying by 9 and I'll be multiplying by y raised to 4. So if I'm multiplying by 9, I'll be getting this as minus 9x raised to 8 is equal to 4 y raised to 4 x raised to 9 plus c y raised to 4. So I'm not writing it as 9c because c anyway is a constant and it can incorporate any constant value in it. So we can just simply write this as c dash. Now since I have said that c can incorporate a constant value, any constant value, we can write it in this format. So let's just see how it is. It's going to be 9x raised to 8, which is going that side, plus 4 x raised to 9 y raised to 4, and I'm taking this that side. And since my c can incorporate any constant value, the minus, when it is going that side, it becomes minus basically. That minus we can take it from the c dash itself. So that will be equal to 9 y raised to 4 c. So that's nothing but your option. Next, going to the next one, we have dy by dx is equal to sin x plus y, tan x plus y is equal to minus 1. So whenever you have x plus y which is present inside a trigonometric function, or basically you see a pattern of x plus y terms or similar pattern of linear terms, always the substitution is going to be the linear term itself, that is x plus y is equal to t. So if I'm doing x plus y is equal to t, I need to differentiate this with respect to x. So that's going to be 1 plus dy by dx is equal to dt by dx. So my dy by dx becomes dt by dx minus 1. So let's substitute in this. So dt by dx, wherever dy by dx is present, it becomes dt by dx minus 1 is equal to sin t tan t minus 1. So 1 gets cancelled out. And now it is of the form of variable separable. Now in this I'm going to be writing this tan as sin t by cos t. So that becomes sin square t upon cos t. So when we are taking the variable separable form, it's going to be of the form cos t upon sin square t dt is equal to dx. Now integrating on both sides, and if I substitute sin t, we can see that the derivative is nothing but cos t. So it is of the form 1 upon x square. So 1 upon x square's integration is nothing but minus 1 by x. So that's becoming minus 1 by sin t is equal to, this becomes x plus a constant c. So now this thing is 1 upon sin t, which is nothing but cosec t. So that goes that side. So I'm getting x plus cosec t, but t is nothing but x plus y plus c is equal to 0. So you can see that the option is nothing but B, because anyway, as I said, c is a constant term, it can incorporate. So I can take it on the other side also and make it as c dash. So that's again nothing but option B. So as you know, for your revision, we ask you set of questions, and the answer for that or the solution for that is provided in the upcoming videos. So these are the two questions which are related to your differential equation topic. I would like to remind you that differential equation topic is important and you need to just practice on this, because there can be at least 2 to 3 questions which are going to be based on this particular topic. So the question is basically you have to find the solution of the differential equation which is given over here. And the second one is nothing but the slope of a tangent at x comma y to the curve passing through this point is given by this equation. So what is going to be the equation of the curve? So this is the problem which is based on the concept of differentiation, wherein slope of the tangent is given. Slope of the tangent is nothing but dy by dx. So basically indirectly they have given you the differential equation. Just give it a thought how you can solve this. We will be providing the solution in the next upcoming video. So thank you guys for watching our videos. Do let us know in the comment section how do you find these videos, whether it is helping you in your preparation or not. Also let us know what more videos you would like us to make on. For those who have been our regular viewers, we would like to give you a good news that we will be starting with the physics section shortly for the Mhtcet, so that it helps you in your preparation. Please don't lose your hope in the current scenario. We know that the CET is being postponed each and every time because of the situation which is going on. The exams are going to be conducted. Please keep in mind and please do prepare and don't give your hopes up. Please do share our videos, please do like our videos, and do subscribe to our channel. To never miss a notification, hit the bell icon. And also stay safe in the current scenario. So keep learning, keep watching, and happy learning. This is Sushant signing off for today.